Hello everyone. A palestra Ready Set Cloud vai começar agora. Espero que gostem.
Boa tarde a todos. Obrigado por estarem aqui. O meu nome é João Fonseca, estou aqui com o meu colega, o Zeeshan. Nós somos da Accenture e vamos falar aqui um pouco sobre Cloud, DevOps. A palestra, parte do Zeeshan, ele vai fazê-la em inglês. Penso que não haverá grandes problemas. Penso que todos serão capazes de perceber. Qualquer situação também eu posso aqui preencher a gap e espero que gostem.
Hello, boa tarde, good afternoon. So I will try to give you an overview about, as my colleague said, cloud and DevOps. So in this session, in this presentation, I will try to make it more generic, not in more detail, in deep, so you cannot understand, or not like baby steps. So I will try to give you an overview what's happening in the cloud industry and about the job opportunities. If like right now as a student, so a lot of people will be confused. Like which field they should start. Either should be like DevOps. There are a lot of things: cloud engineer, DevOps, network engineer, system engineer. So I will give you an overview of all of these. So about the IT industry, like how many fields we have and how many sub fields we have within those fields. So I will try to give you an overview. Okay. Hopefully in the end of this session, you will have a clear picture what's happening in IT industry and what should you do where we have a lot of opportunities, and regarding your career, like how you should proceed. Like if someone is in first semester, what he should do before, like start coding, then this. So I will give you an overview of everything. So next. Okay, so this is an overview. Like in IT industry, we have a lot of fields, like 100 plus fields. Someone is a network engineer, someone is Python, like coding, he is doing in coding in Python, someone is doing coding in Java, .NET, PHP, cloud engineer, security expert, blah, blah, blah. We have a lot of things, right? So in this session, I will try to give you an overview like what we have in main hierarchy. We have network simply. So in network we have a lot of fields. Someone is Cisco certified, someone is Huawei certified, and similarly there are a lot of vendors. So it is all rely within network. So like lot of firewall, someone is doing firewall configuration on some cloud. It could be Amazon, it could be Google, it could be Microsoft Azure or something. Someone is configuring firewall locally, like in everywhere we have a data center. So someone is configuring firewall manually on their own local data center, right? So whatever we talk about network, so the main thing is network. Within network we have a lot of fields, subfields. So it's all about network. Okay, so this network could be on Google, on Amazon, on Azure, on DigitalOcean, IBM, anywhere, right? If someone have a basic understanding of the networks, like what is IPv4, IPv6, how it communicate, how whenever we send a request, how it receive. So if someone know all the communication, they can understand the networking. So it doesn't matter if you work locally, if you work on Azure, if you work on Google Cloud, you can work anywhere because you have base, right? So whatever we have in networking, it's so in networking, main is network. Within network we have a lot of subfield. Okay, and in data, so in data we have a lot of fields. Someone is working on MS SQL, someone is working on Oracle DB, someone is working on other databases. We are talking about a lot big data, data analysis. So this is all about game of data. So within data we have a lot of subfields, right? If you have a basic understanding of data, like how we can fetch the data, how we can organize the data, so you can work anywhere. Like if you have some experience during your semester, like you completed some project of databases and you configured an application with your database, it's working. So you have a basics of databases, so you can work anywhere. It doesn't matter if it's a Google, if it's Amazon or anything, because you have a base, right? So in programming could be someone is .NET, someone is Java, Python, PHP, anything. So it's all about programming. Do you know about OOP, object oriented programming? So that is the main scheme to write a program, right? So if someone know that scheme, how we can call our class, again subcall, object, classes, if you know this scheme, you can work on any programming. Like suppose if you have made your hands dirty with some .NET application, some .NET programming, if you want to switch on Java, you can switch after like 3-4 months, 3-4 months effort, right? Because you have some understanding of the programming, right? So whatever we have in programming, we have multiple fields, like someone is .NET, PHP, Python, blah, blah, blah. We have a lot of, right? So the main field is programming, okay? In artificial intelligence, we have a lot of fields. Nowadays, we have bot, we have robot, we have many things in artificial intelligence. So main field is AI, right? So similarly in security we have a lot of security, like it could be a security you are using on your mobile phone, MFA, multi-factor authentication, it's a part of security, right? So to attend this session you need this card, so it means it is a part of security. So security can be like physical, security can be on mobile, security can be on laptop, anywhere, right? So if we're talking about security as in IT field, so in security there are a lot of subfields, like it could be like in a data center, it could be a physical security, like nobody is allowed to enter in a data center. They should have some kind of authentication. It could be thumb authentication, it could be face detection or something. So this is a physical security. Similarly, in IT industries, we have security like how many people know about SQL injection? SQL injection. So SQL injection is like if you have bad programming in your code, so it could impact SQL injection. Like someone can write some script and can inject in your code and can enter in your application. So it's a loophole for someone, hacker or someone. So someone can enter in your application and she can create a mess, right? So by considering security, there are a lot of fields. It could be a code security, it could be a network security, it could be a server security, it could be any other kind of security. So if we talk about security, there are a lot of fields, right? Next.
Just to complement on what Zeeshan said, these fields in the information technology industry are, as you see, part of some parent field like network, data, programming, artificial intelligence, and security. A few minutes ago, a colleague of you were asking, hey, I only spoke about cloud in my 4th year, why we did not speak about this earlier? And what Zeeshan was trying to explain to you also is like that during your course, most likely, you will only pick a very few items of this, as you probably want to get more into like programming. I want to know about ChatGPT and language models, about SQL injection, like hacking and stuff like that, network sniffing. You probably want to do that. But as a first step, and you probably are doing, you are approaching all these fields in this first line here, so you can have an understanding of everything. And don't worry about, okay, like cloud is not like a new discipline. If you know this, and if you can work on any of these, like any language, any object-oriented programming, you will be able to work and make a shift to a different language, a different flavor, a different tool. And same is for the cloud. If you know to work on this, you will be able to work on the cloud as well. You just need to know the nits and bits to take the most of it, but it's not something you need to learn specifically. Learn how to cloud, let's put in these words. It's not necessary. If you have the basics, and if you know 1 or 2 tools of this one, you will be fine, all right? Thank you.
Okay. Okay, so here I will give you an overview because a lot of people are confused about what is hybrid cloud, what is public cloud, what is private cloud. So like public, private, everyone knows. What is hybrid? So how it works? So the cloud, what is cloud? Cloud is a like combination of multiple, you can say, devices. They are connecting, they are communicating with each other. In the beginning, there were like few hundreds of PCs who were sharing their data. Right now, like everyone in the world, they are sharing their data, like same as torrent. So in torrent, you have a seed. So seed means you are getting something. If like if someone is near to you, they have downloaded that movie or something, so you can get that video easily. So what does that mean? It means you are using seeding, right? So I will explain this maybe later. So it will be, so cloud is a combination of multiple devices, like all over the world we have a lot of devices and everyone is connected with a centralized system, so that is called cloud. So it could be like now we have a different brand, we have Google, we have Amazon, we have Microsoft, we have IBM, DigitalOcean, multiple, right? So the cloud is combination of devices. So what is the benefit? Benefit is like we have some kind of on-demand self-service. Okay, so on-demand self-service is like pay-as-you-go service. How many people know about pay-as-you-go? So pay-as-you-go service means like you are using Google Drive, right? So you have, whenever you create an account, you have some limited storage. If you want to buy more, you can buy, right? So similarly, if you're working on some other cloud like Microsoft or something, you create a VM, some storage. So, and you need that virtual machine for a specific time, right? So they will charge for that specific time. If you turn off, so shut down the VM, so they will not charge. So it means whatever you use, you will pay for it, right? So it means we have an on-demand service on a cloud. Whatever you want, you can get from different cloud vendor. It could be Google, Amazon, anywhere, right? So rapid elasticity. So rapid elasticity means you have one application. We can say it could be Sigurancha Social website. So in the beginning, like we have limited user, and with the passage of time, users are increasing. So that website, that server in the backend, we have like 10 servers. So those 10 servers cannot manage the load. So whenever we have a lot of load, so it means we need more resources, right? So in that case, if you want to extend the balance, load balancing, so it is possible on cloud. So you can easily scale your application, right? So measured services, you can measure like whatever happening, so you can easily check all the stats. Internet access, so it means if you want to share something, like it could be a document, you can send easily with someone by using some drive, Google Drive. If you want to share your thesis or something, you can send an email and your professor can get. So it means it's the beauty of cloud. Okay, next. Okay. In the beginning, what was happening? Like here, I will give you an like touch of job shift, like how jobs are creating in the industry and how we can utilize with this process, like where we have a lot of jobs. Okay, in the beginning there were physical servers. So at that time, the companies required someone who knows what is RAM, what is storage, and how to set up a big server. So at that time, companies were hiring people who have a knowledge of that kind of hardware. So at that time, there was a need of an engineer who know about the hardware. Okay, so at that time, so there was a job for that kind of person or that kind of engineer. Later, when virtualization was introduced, okay, instead of creating a physical server, you can create a virtual machine. Before this, there was no concept of virtualization. Now you easily can create a virtual machine by using VMware, Hyper-V or something, right? In the beginning, it was not like that. Sometime for some user, they need to enable virtualization manually from the BIOS. It is not enabled by default, right? So when they introduced virtualization, okay, instead of creating one dedicated server for one application, we can create multiple applications within one server. So that was the concept of virtualization. At that time, there was a lot of job of people who know about virtualization, who have concept of virtualization, like how they configure virtualization. It could be VMware, it could be someone, okay? So after this, nowadays we can say is a cloud, okay? Instead of if you are going to configure your own data server, there are a lot of things, like when we can say someone have their own company, what are the basic things to start a company? So first of all, you should have your own email ID, right? If you have a dedicated email domain, then you can say, like in Accenture, if you have Zeeshan.Hurmat at Accenture, so it means now it exists in IT domain that you have a company. So you need email server, you need lot of resources, right? So it means you need your own dedicated data center. So it could be in your company, it could be somewhere, right? Okay, to set up a data center, your own data center, there are a lot of things. You need to manage electricity, you need to pay for resources, you need to pay for storage, RAM. Suppose on a big server, there is just one application running, right? So to make that application running, you need to make sure that your complete server is up and running. So it means you are spending a lot of just for one application. So in case of cloud, this is the beauty of cloud. You don't need to set up your own data center. Like big companies, they can afford their own data center, but small companies, they cannot afford their own data center locally exist. They need to make sure their physical security, they need to make sure some other security. So that's why when these cloud vendors, Amazon, Google, IBM and everyone, they provided some solution. Okay, you can use our resources and we will make sure the security and everything, and also we will sign SLA. SLA agreement means, like if something is stored on Google, Amazon or something, if your application is down for some time due to some problem at Amazon and Google and Microsoft, and they will pay you for this. So if someone is giving you a lot of benefits, so why not small companies move to Google, small companies move to cloud. So here the concept of cloud exists. So why we need cloud? To manage all of this, right? Nowadays we have a lot of cloud, Amazon, Google, IBM, everywhere, right? So at this shift from physical to virtualization, virtualization to cloud, nowadays, or like 5 years back, there were a lot of jobs of cloud engineer, the people who know about the cloud, how they can move their existing application. Like suppose we can say Nosh have their own data center and everything. Now they need someone, like Nosh is moving to some cloud, okay? So Nosh needs someone who have experience in a cloud so they can move their application without any downtime. For these companies, downtime is big thing. They cannot afford 1 minute downtime, like Nosh is, like Facebook is down just for 1 hour. So everyone is blocked, right? So these big companies, they cannot afford downtime. So they need someone who is very expert and who have some tricks, some skills. So without downtime, they can migrate their application from local data center to cloud. So at this stage, at this time, there were a lot of job of cloud engineer. So if that company is moving to Google, so they need someone who have a Google cloud experience. If company is moving to Amazon, they have a project, they need someone who have an Amazon experience. So here, there are a lot of opportunities, lot of jobs of different cloud. If someone have a lot of experience in multi-cloud, what is multi-cloud? Multi-cloud is you have experience in, so multi-cloud is a company, they have their own data center, they are using some resources on public cloud. We can say it could be Segurança Social. So for publicly, they have available something that is on public cloud. Something which is sensitive or due to security measures, they are using, they are keeping those data locally. So it means if something is connected locally and connected with public cloud, not just one. Like they have some resources on Google, they have some on Amazon, they have some on Microsoft Azure. So it's a combination of multi-cloud. So if you have more experience in more cloud, you have more opportunities. It's very simple. Microservices and containerization. So once we already have cloud, so it's a era of cloud. Now there are a lot of jobs of someone who can, like at this stage, virtualization, we are moving VM to cloud. Now we have virtual machine on cloud. We need someone, like you are spending, like someone is spending 1,000 euro per year for one VM, and XYZ give them solution. Okay, if you spend 50 euro per year, you can manage your everything as it is. So she is introducing a technology which is called containerization. Like if you have your own laptop, you have 8 GB of RAM, so you can run 2 VMs, maximum 3. On the same machine, you can run 200 plus containers. So if someone is giving you a solution of containers and reducing your cost, for someone who is an investor, for investor or company or someone who is that is not a technical person, for them money is everything, right? So if someone is giving them solution that we can reduce your cost, so why not that owner, CEO or someone, he will say, okay, use this technology. So at this point, they need someone who can help to move their resources from virtual machine to container, right, and microservices. So at this stage, if someone have experience in microservices, container, there are a lot of opportunities, and it still have. It's the same thing. This is the last one, infrastructure as a code. Okay, so recently, not recently, like few years back, it happened that Facebook, WhatsApp, Instagram, everything was down almost one day. It was down worldwide. What was the reason? The reason was someone messed up with their DNS configuration. So if you try to access that on their public, like facebook.com, it was not accessible. But if you know the actual IP, it was accessible. So reason was something they messed up with the DNS. Okay, like big companies, like they have a lot of resources in their infrastructure, in their data center. If someone messed up, if like it could be someone or it could be like it could be anything. In case of disaster, in case of problem, if something messed up, how you can recover quickly. So this is the solution. Instead of physically accessing everything, you are doing everything like designing infrastructure by code. You are just writing the code. With this approach, infrastructure as a code, you don't need to give access to everyone. Like we have 20 DevOps engineer, you don't need to give access of Microsoft or something. Okay, you can start playing with this. No, everyone will commit their code to GitHub, GitLab or something. It will execute and then it will deploy. So this is the beauty of infrastructure as a code. So here we have a Terraform, Helm charts, all of this. So Ansible playbooks are also part of this, that we are designing infrastructure with the code. Nowadays, it's highly demanding. This because with this approach, you are increasing security, you are making things more automated, like it is running automatically. You don't need to give access to everyone. So right now, this is the highly demanding skills in the industry. Data center, physical to virtualization, virtualization to cloud to microservices, container to we are here right now. So within this process, there were a lot of jobs created in the past and still creating. There are a lot of jobs, like if you have these kind of skills, you can easily get a job. Okay? Next. So this is an overview, like hybrid, multi-cloud, single cloud. Single cloud is like, it is single cloud, you have your own data center, maybe it could be A company, they have like 3-4 offices, they have connected their offices, so that is called intranet, that is called their internal cloud. So hybrid is like they have their own cloud, they have their own data center, plus they have their own data center, plus they have some resources publicly available, so that is called hybrid. So whatever they want to keep secret, so they will keep those things locally, whatever they want to expose, they can put on public cloud, so that is called hybrid. So multi-cloud is an example, like one company using multiple clouds, so that's called multi-cloud. Next, so it's, so I was trying to give you some kind of calculation, like 39% they are using hybrid, 30 plus they are using this, so I was trying to give you this calculations. Next is, no worries, so I can cover here. No worries. Okay, so public cloud providers, we have a lot of, as I mentioned, there are a lot of, like Amazon, Google, IBM, DigitalOcean, there are a lot of. Okay, next. No worries, you can go to next, I can manage. Okay, so here I have, so back please. This one is like, no worries. So that was some kind of stats that IBM is using this, DigitalOcean is using this. So here it is a comparison of different cloud. So like it could be a question, which cloud is better? So there is no answer for this question. So someone have, so right now they are all good. They have, if some cloud provider is giving you some kind of solution which can reduce your cost, it's the best for you. That's like, if you are going to use some service which is available on Amazon, which is cheaper than Google, so it's best for you. So, so this one is more comparison about the market stock, like how they are managing. Okay, maybe next.
The next one.
Okay.
So, eu vou fazer o shift aqui para português para também não se cansarem do inglês. O Zeeshan teve até agora a explicar os vários providers de public cloud que existem e a forma de chegar lá e como é que isso afetou, a indústria da cloud afetou a criação e os novos empregos que têm surgido através destas tecnologias e todas estas as portas que a cloud abriu em termos de um profissional de informática. Como vocês devem ter percebido, no início havia vários empregos que faziam sentido na altura que hoje já não fazem tanto sentido e vocês, enquanto estudantes, estão se calhar preocupados qual é o caminho, como vimos naquele primeiro slide, com tantas áreas, tantas tecnologias, tanta coisa possível para se fazer em informática, qual é a melhor opção, onde é que eu me encaixo e onde é que eu vou também ser mais bem pago, não é? No fim, é o que também interessa a toda a gente. Na cloud, e porque é que isto é trend hoje em dia, nós temos aqui os principais benefícios da cloud em comparação com a approach normal de teres a empresa ter o seu próprio data center e ter que lidar com toda a infraestrutura e com a segurança. Nós temos a escalabilidade, a poupança de custos, a automatização. Este up and down significa poder aumentar ou diminuir, a gestão de operations, disaster recovery, que é quando as coisas correm mal, como é que se repõe o estado anterior. Serverless é um outro aspecto importante, se calhar no próximo slide vamos falar sobre isto, e a reliability. Na vossa opinião, o que é que vocês acham destes benefícios? O que é mais importante? Qual deles é que faz, enquanto um CEO de uma empresa diz, ok, vamos meter isto na cloud? O que é que vocês acham destes benefícios? Qual é o que mais chama por um CEO? Custo? Disaster recovery, reliability? Engraçado, ninguém falou em scalability. Sim, o custo é um grande fator, embora isso depende muito do use case e da dimensão da empresa e da aplicação e da user base, ou seja, o número de utilizadores. mas a reliability e a scalability, principalmente. Porque isto está, de certa forma, relacionado com o custo. A scalability é muito importante, porque vamos imaginar uma empresa que, caso do CTT, sei lá, durante todo o ano tem um volume mais ou menos normal de negócios. Chega a altura do Natal, é encomendas para todo o lado, é pico de utilizadores, toda a gente a querer factory tracking das encomendas e tudo mais. Num molde antigo, eles têm que projetar toda a infraestrutura para fazer cover desse pico de utilização, senão, simplesmente, o sistema não vai funcionar e as pessoas não vão poder usar na altura mais crítica, onde eles fazem mais dinheiro. Ou seja, tem que projetar uma infraestrutura, comprar servidores, RAM, CPUs, tudo, para uma utilização que só tem um pico no Natal. E o resto do ano, aquilo está praticamente às moscas, não é? Portanto, a cloud resolve este problema na medida em que a escalabilidade, como vemos aqui neste gráfico, nós podemos definir uma baseline, ou seja, a qualquer instante não pode ir abaixo deste número de máquinas e de servidores e de recursos. À medida que os utilizadores, a utilização cresce, por exemplo, num período de Black Friday, de promoções, de Natal, a utilização aumenta e todos estes recursos vão escalar automaticamente com base nessa utilização. Eles, nessa altura, como o Zeeshan explicou há pouco, isto é um modelo de pay as you go, só se paga por aquilo que se usa, portanto, se a máquina estiver desligada, não se vai pagar por ela. Nessas alturas, eles vão ter um custo superior aquele mês, mas ninguém vai ficar a aplicação não vai ficar indisponível, ela vai ser utilizada. Portanto, isto é um dos principais fatores que levam uma migração para a cloud e está, de certa forma, relacionada com o custo, diretamente relacionada por o custo, que eu, em vez de ter comprado toda uma infraestrutura para suportar o pico, vou usando só aquilo que eu necessito em cada dado momento. Numa altura menos utilização, pago pouco. Quando necessito de mais, nessa altura pago mais e aí vai. E a outra parte é a parte da reliability, só que aqui há algumas nuances entre a segurança e tudo mais, e eu vou falar um pouco mais em detalhe desta a seguir. Reliability também é provavelmente também uma das maiores razões que levam uma empresa a mudar para a cloud. Vocês veem aqui, há um modelo de responsabilidades partilhadas, não é? Em que a empresa deixa de ser totalmente responsável por tudo. Se os servidores não são meus, se não é o meu data center, eu não tenho que lidar, por exemplo, com o controle de acessos, quem é que anda a entrar e sair, se as pessoas que lá estão a trabalhar não estão a tirar dados, coisas assim. Portanto, é uma responsabilidade depois do provider, seja ele qual for. Os SLAs, isto foi falado também pelo Zeeshan, que é uma garantia que os providers dão, o SLA stands for Service Level Agreement, é uma garantia que eles dão, por exemplo, este serviço vai estar disponível com um uptime de 99,9999%, isto normalmente é medido no número de noves a seguir ao 99%. Em que, basicamente, se eu não me engano, 99,99, eles garantem que é menos do que 5 segundos em um ano. Ou seja, a aplicação, no total, num ano inteiro, nós garantimos que ela só vai estar indisponível durante 5 segundos. Durante um ano inteiro. Outras aplicações, principalmente na área da medicina, por exemplo, ou sistemas de navegação aérea, tudo mais, tem à volta de 10 noves, ou seja, é muito, muito, muito reliable. Ou seja, ele é um downtime de 10 milissegundos num ano, uma coisa assim. Portanto, é mesmo quase insignificante. Onde é que isto seria possível? Ou qual seria o custo para se conseguir isto? Com um data center, ou seja, se a minha empresa se dedicasse a uma aplicação desta natureza, qual era o custo para mim, em termos de redundância? Eu ia ter que criar para aí 5 servidores em zonas diferentes para garantir que isto nunca falhava ou que só falhasse 10 milissegundos num ano. Portanto, sujeitos a todo o tipo de problemas de falhas de energia, de tudo possível e imaginário que pode acontecer. E isto, de repente, na cloud está acessível imediatamente para qualquer um, para o comum dos mortais, não só para as big corporations, nem nada disso. IAM, Identity Access Management, a gestão de acessos, é uma responsabilidade. High Availability é o que eu acabei de falar, relacionado com os SLAs, em que determinadas aplicações, principalmente na área de saúde, controle aéreo e tudo mais. Outra questão muito importante é encryption. Encryption, regra geral, a criptografia requer chaves, certificados. Um certificado para um simples servidor, para um domínio, chega a custar 500 euros por ano, dependendo do grau de robustez, pode até ser mais. É utilizado em muitos outros pontos, até para armazenamento dos dados. Quando os dados estão armazenados nos discos, têm que estar encriptados, ou convém que estejam encriptados, principalmente se são dados sensíveis, dados pessoais. E isto é tudo seamless na cloud, eles tratam disto, não tenho que me preocupar, nem ter que adquirir, é muito mais fácil. Outro ponto é o compliance. A partir do momento que uma empresa vai internacionalizar-se, cada país tem a sua legislação, cada país tem as suas regras ou leis, e a cloud aqui ajuda também esta parte da compliance, em que eu não tenho que estar aqui a designar e a contratar pessoas em cada país ou em cada ponto em que eu estou para fazer face a essas exigências e essas regras e essa legislação. Ou seja, o compliance aqui também é facilitado. Portanto, todo isto é um modelo partilhado em que muitas das responsabilidades que estariam a cargo de um CEO ou da pessoa que está à frente da empresa passam para a cloud. Portanto, não é só as pessoas quando pensam qual é os benefícios da cloud? Ok, vou pôr isto na cloud. Eu vou pôr, em vez de ter a máquina aqui à minha frente, a máquina está num servidor, algures, num data center qualquer do mundo, da Google ou da Amazon, ou o que seja. Mas, na verdade, nós estamos a passar muito mais e, principalmente, muita responsabilidade também. Por isso é que é um grande atrativo e é muito mais fácil para uma empresa, principalmente uma empresa nova, que não tem capacidade de gerir todo um data center, facilita imenso, não é? Não ter que lidar com todas estas coisas e poder focar-se mais no negócio e na aplicação e no serviço que está a prestar. Portanto, é uma abstração incrível que não tem preço quase, não é? Next. Now I will hand over back to Zeeshan. You can explain a little bit about DevOps. And he will explain this, one of the new jobs that appeared and that takes most out this cloud technology.
So I will, due to shortage of time, I will try to explain quickly. Okay. So what is DevOps? A lot of people are confused about DevOps. So like if someone have experience in a coding, so he can move to the DevOps or not. If someone have background of network, server or something, so he can be a DevOps or not. Okay, so this is very interesting discussion about this session. What exactly is DevOps? Okay, so go back please. We have like DevOps. What is Dev is development, ops operation. So what is operation? Like someone is a developer, he have set up everything on their local laptop, it's working, application is up and running. Okay. Now they will send that application to operations team. Operation team could be someone who will configure rest of the thing. It could be like server configuration or something. So that is called operation, right? So if you have application developed, it will be moved next phase to the operation. So DevOps is a combination of both. How? So if you have set up the application, you will give that code manually to someone, he will configure rest of the things, so then it will be up and running. In a DevOps, what we do, we make things automate. If someone is a developer, they will commit their code, it will automatically execute all the phases. So what are the phases? Like we have different kind of applications. Some of them are like scripting languages, like but .NET, Java, we cannot deploy those applications directly. We need to make a zip file or build or package. So we can only deploy application after making a package. So package configuration is always taking some time, and so every time you need to move your code, you need to make a package. So the process of making a package like zip file or something, and there are some more steps like pre-step, post-step, something like that. So there are a lot of phases. So in a DevOps, what we do, we make process automate. We get the code, we make automatically unit testing, like to test the code if there is, so this coding mechanism is following as per requirement or not. Is there any security vulnerability or something? So we scan the code. After scanning the code, we make a build, then we deploy. So deployment could be on something, it could be on VM, it could be container, it could be anything. The process of making this the process of making these things automate is one job as a DevOps. This is just a one job. This is not all DevOps. As a DevOps, you need to work on Docker container, you need to work on Kubernetes, you need to do a lot of things. So in short, in DevOps, the process is to make things automate. Get the code, automatically do everything. So if someone have experience, someone know the techniques, how to automate things, that is called DevOps. Similarly, there are two more fields, DevSysOps and DevSecOps. If someone have interest in security and he wants to gain a job in industry, so what she should do? So if someone have a background of security or someone have interest in security, so there is a field which is called DevSecOps. In this phase, we are deploying everything on a container and we are moving to code as a service. So we need someone who can make some security process, security mechanism to test the code, to analyze everything. So there is a field which is called DevSecOps. If someone have experience in a system side, like server configuration, it could be Linux server, Windows server, it could be anything, right? So if someone have a background of system side and he wants to gain a job in industry, there is a field which is called DevSysOps. Okay, so similarly, it could be SysOps engineer on AWS, SysOps engineer on Google, SysOps engineer on Microsoft. So if you integrate DevOps as a system engineer, so that is called DevSysOps. If you integrate DevOps with security, that is called DevSecOps, right? Next, please. So it is the same thing I explained, reliability, security, and everything. Next, please. So before DevOps, what was happening? Before DevOps, you need to give code manually. It could be a shared storage, it could be something you are pushing the code to that storage, and someone who is in operations, he will take that code, he will make a build, and he will deploy the application. Okay, so with DevOps, we are automating this process. So in the in the past, it was very difficult. Like, so before starting Git, so it was also difficult. Like there, only one people can work at a time. So we automate this process, or we solve this problem by introducing Git. Similarly, the integration or deployment of the application problem solved with DevOps. So we have a DevOps. So if there are like 100 plus DevOps engineer, they are working. So, there are 100 plus developer, they are working. So we can create different kind of environment for them. They will just commit a code, it will be automatically deployed. That's it. Next. Okay, so after DevOps, these things became easy, automate. With DevOps, you don't need to give access to everyone. Like suppose you have a Linux server, Apache, you have installed Apache, Nginx or something, you have a PHP application, it is up and running, right? There are like 100 developers who are working on that application. So you don't need to give access to all 100 developer, okay? Once you test your application, you can log into this server and you can deploy. Maybe on that web server, we also have like 100 plus application. So XYZ developer can mess up with other applications. So with this approach, with DevOps mindset, we can reduce security. Oh, sorry, we can reduce security risk, okay, and we can increase security. So we don't need to give access to everyone, right? So that is a plus point. So also with Terraform, even though if someone is a DevOps, like there are 10 DevOps, so you don't need to give access to 10 DevOps. You will give them access of Git, okay, push your Terraform code here, it will automatically execute. Even though nowadays there is a strategy which is called code as a service. With code as a service, even though system engineer, network engineer, DevOps engineer, DevSysOps engineer, DevSecOps engineer, they don't need direct access. They will also write code. So they need someone who can do this job. So there are a lot of opportunities with this approach. Okay. Sorry, you want? Okay. So next maybe. Okay. So anyone have any question, doubt, anything? If someone asks, yes, yes. Yes, please. Okay, so we have booth outside. So Accenture, you can come there if someone have question. So we will try to make it clear to you. Maybe more discussion. Okay. Thank you so much.